Whenever we have calculations that require repetitions, we can code up these commands into either a for loop or a while loop. This is the general structure of a for loop. There will be a variable that will change in value with every pass through the loop, and the variable is specified in between parentheses, and in between braces we have the commands to be executed inside the for loop. Here's an example of a small program in R. The most important part of that program is the calculations that are computed inside the for loop. The variable of this for loop is n, and it takes values between 2 and 10. Let's code up this small program in R. What we can do is in RStudio, we can go and visit this tab and choose R script, create a new R script. I'm running RStudio in Mac OS X. If you're running this on Windows or Linux, then your display of RStudio will look a little different, but you can always create a new R script by going to the menu under File. So as soon as I click this, a blank page appears. This is the editor of RStudio, and here's where we will start typing commands, R commands. For example, we want a for loop, and in parentheses we say n in 2 to 10, and we're going to write more commands here. So this will be a good time now to save this file. I go and select this tab. We have the cursor here with a little floppy, and I will be given the choice to select the name of the file. Automatically R will save this with an extension .r. What we're going to do now is that you're going to type all these commands into an R script, and you're going to save that R script. So we're going to pause the video. You're going to pause the video right now, and you're going to take a few minutes to type in all these lines of R code. So now that you have typed all those lines of code, we have this little program. In this case, this script is called loop1.r, and one thing I'd like to point out to you: when you have an R code, look at the characters that are typed in front or after the hashtag, the number symbol, the pound sign. This hashtag symbol in R, any character that appears after that is ignored. So R ignores any characters after the hashtag, and that's what is used in R programming for writing comments. Comments in your code are extremely important, especially when you write programs that have a lot of several lines of code. This will help you, this will remind you of what each portion of the code is doing. Okay, so hashtags are used for comments. In this code, we have a variable called init size, initialized at the value of 4. Then we're going to have another variable called pop size. This is a vector. We can type here rep 0, 10. Then this is a vector that is first created with zeros, with 10 zeros. And the first entry of this vector is filled in with the value stored in the variable init size. In the for loop, we have two calculations. First, there is a calculation that involves a multiplication. Then there is a calculation that involves taking the logarithm of the previous calculation. And then there is a command cat. Okay, so let's say that we're considering pop. I just want to show you this. Pop size is rep 0, 10, and then we said the first entry here is going to be, in this case, is going to be stored with the number 4. So what happens when n is 2? The first value of this for loop is n equals 2. Then pop size of n minus 1, which would be 2 minus 1 is 1, that has a value of 4, and if we multiply that by 2, then that now has the value of 8. So when n is 2, pop size of 2, let's, when this was first created, pop size of 2 is storing as 0, but on the first pass of the for loop, that 0 will be replaced by the number 8. When n is 3, the third entry of pop size will be replaced by 2 times pop size of index 2, and so on, right? So that is the idea of executing this for loop for different values of n. And the other thing that happens here is that the cat command is converting the values that are two arguments here, n and x. N is the value of the iteration, and x is the value of the logarithm of pop size. Both of those are numerical values. The built-in function cat converts these numerical values into character strings, and it glues them together, and it prints them to the screen. Okay, so now I'm going to execute this program. I can highlight all these portions of code. Then I go to this, I put the cursor here in this tab that says run, and then I hit run. And you can see how in the console we're getting some output. These are two columns of output. The first is the value of n, the second is the value of the logarithm of pop size, right? So this goes, is printing n and takes values between 2 all the way to 10, and this is how we executed our first for loop. Turns out that we can do even more sophisticated things with for loops. For example, we can run nested for loops, or we can run sequential for loops. Nested for loops means that you have one inside another loop, and sequential for loops means that one loop starts after the previous one ends. Okay, this is an example here of a situation with two for loops that are nested. Okay, this is the same type of calculation we just executed. We initialize this a little shorter now. This is running from 2 to 5 instead of 2 through 10. And previously we had initialized with a value of 4. So now the idea is, what if we have three different initial values: the value of 1, the value of 5, and the value of 9. Okay, so let's type this code into an R script and let's execute it. So suppose that we type this into a script, and now we save the script with this name loop2.r, and we execute this. The command cat now is printing the initial value. So we have an inner for loop that is carrying out that calculation of multiplying the previous entry of the vector times 2, and the outer for loop is executed for each initial value, right? So then the what is being printed to the screen is the initial value, the iteration value that that we have here, this variable n, and the value that we store in the vector. So let's highlight this portion of code, hit run, and here we have the output. The output is now 3 columns, right? One has the value of init in the variable init, the other one has the iteration value. The inner loop is running from 2 all the way through 5. So we can see that with the value of 1, we have this display, and then this is executed with the value of 5, the initial value 5, and then it's executed the initial value of 9. So this is a very simple example of a situation in which we have two for loops that are nested, one inside the other one. Conditional statements are important when we are dealing with logical operators. This is this is convenient, especially when we're trying to do comparisons between variables. And this table here summarizes some of the most standard comparisons. In fact, we're going to try this. We're going to type question mark comparison. So let's switch into the R console. So we're going to type here comparison. We're interested in comparison and hit enter. And we can see how we get a description here. Let me stretch this a little bit. Right, what we're accessing using the question mark is the documentation in terms of operators that allow comparison. Okay, so there is details of how these comparisons are handled in R. So let's work some examples where we are using the some conditional statements. Say that we have variable A, which stores a value of 1. We have a variable of B that stores a value equals 3. And now I would like to compare A and B. So is A less than B? So this is basically a question, but I'm going to store that into yet another variable that I'm calling C. Okay, and I'm going to print C into the screen. So C now stores the value, which is a logical value. In this case, this logical value is true because 1 is strictly less than 3. What would happen if we do a similar comparison the other way? Is A strictly bigger than B? You can also, when you're doing this type of logical operators, you can specify this with parentheses and here print the letter D, and then we can see how this is false. So we could do this type of thing when we're comparing vectors or comparing values in a vector to a scalar. So let's say that X is a vector that stores values 1 through 5. And now let's ask the question, is X less than or equal to 3? And in fact, I'm going to store this in a variable that I'm going to call Z. Okay, and now we're going to print to the screen those values. So we can see that this is true for the first, so here are the values stored in X. The first 3 entries of X are less than or equal to 3, but the last 2 entries are strictly bigger than 3. So that's why this stores values of false on the last 2 entries. A while loop has the same spirit, is a repetition like for loops, but this is the general format or the general structure of a while loop. The conditions specified between parentheses, and between braces we can specify the commands. Here we can have a temp variable, some kind of counter variable, which we initialize outside and update inside the while loop. Okay, so let's see, sometimes it's possible to have a loop in as a for loop or convert that into a while loop. The most important thing is that the while loop is going to execute the commands provided this condition is true. Okay, so the while loop involves a conditional statement. This program is another version of the calculation we were executing with a for loop, but here in this loop we have a while loop. The condition is that this variable pop now is strictly less than 1000. So there are two variables, pop size and pop now. There's still the variable with initial value, with initial size, and the calculation is basically the same we had before. We multiplied by 2, and this point here, this is how the current value and the previous value are pieced together. So we can highlight and execute this program, and here we have a beautiful output which is plotting the values on pop size. And I will leave you with this so you can copy and execute this program. And this concludes our conversation about iterations with for loops and while loops.